Here's another example where you can see if you understand the idea of pass by value. So everything on the left is, as it says, executed in the command line. Or you could write it as a script, but executed in the command line, and then you call the function. So I'm actually telling you what the function is so that you can see what the output would be, but reality, you don't even really need to know how it does it, you just have to know what they are. So anyway, I mean, you kind of got to know. But anyway, so here's the blah function. And I typed a equals 3, b equals 5, and t equals 2. Then I have that r, s are the two outputs of the blah function, t and a. So before I run this, I would like to go check and see. Now remember, as the user, you're not even going to look at this. This is completely gone. I mean, from somebody who hasn't written it thing. So I can use this function without knowing what it does. So come over here and think about, okay, well, what would this actually do? Pause the video. Make sure you learn stuff because, you know, learning is important. And what kind of wall it's going to be now? It can't be a pirate wall anymore. We had a pirate wall, and we've had like a regular wall. This could be like a, oh, we had a rocket wall before. We had a pirate wall and a rocket wall. Could this be like a kitty cat wall? No. I'm just drawing to give you a chance to convince yourself that you can indeed stop the video and work. It is like the ugliest cat I've ever seen. Oh my. Make it slightly smaller so it's maybe less offensive. But anyway, we have a kitty wall. Okay. So we have a is equal to 3, and we have b is equal to 5, and we have t is equal to 2, and we have that r and s are equal to something. What is it? I have no idea, but it's going to be blah function of 2 and 3, because that's t and that's a. Remember that MATLAB and most programming languages in general do not send the variables over. You have to really work hard to make that happen. Instead, it sends over the value. Pass by value, always equals. Okay, so then our blah function is a and b, of a and b. So you say, oh, so the problem little function thingy is like, yay, thank you for the inputs and stuff like that. So that must mean that a is equal to 2 and b is equal to 3. Because it has to be, because the first one's A and the second one's B. It's like, thanks for that information. I'm like, okay, no probs. Then we have A is equal to A plus B, which means it's 5. And A has been overwritten. Then we have X is equal to A plus 6, which makes it 11. Then we have B is equal to negative 2, which is like, well, why did you want B in the first place? I don't know, just bad code. And then T is equal to X plus A plus B, which is 11 plus 5 plus b, which is some kind of number. What's 16 minus 2? 14 maybe? Yes, 14. Okay. So t is equal to 14, and y is equal to 3. Now there's two outputs for this function. The outputs are x and y. So it's like x and y. So 11 and 3 are the outputs for the function because they're x and y. But of course it doesn't send the actual variables, it just sends the value. So we put on our, I'm tired of drawing wings. Well, it kind of flies. It's a weird flying machine. Make it smaller so it fits better. And remember what happens when it passes over the magic kitty. The magic kitty then comes along and goes, and it's all gone. And all of this disappears forever because the function's closed. It's all done. So the 11 and the 3 come over here, and these come equal to r and s. So specifically, I can say that r is equal to 11 and s is equal to 3. And if someone was to come along and say, but wait, I thought b was negative 2, it's like, but you see a negative 2 here? Well, actually, you see negative 2 here. The answer is no. Even though what happened here doesn't matter because it's all gone. Because as soon as that function closed, all of those values went away. So if you don't see it over here, it does not exist. So r is 11 and s is 3, and that's really what we should end up getting. If I run this, t and a, 11 and 3.